Hello and welcome to your second strings lecture. So last time when we talked about strings, we talked about how they're collections, which basically means they're multiple objects put into one bigger object, and we can slice them or grab individual objects using indices. We also talked about the in operator, which allows us to check if a smaller string is inside a bigger string. This time, let's talk a little bit about string comparison. So we've talked about comparison operators when it comes to numbers, and we've actually used comparison operators like the equals to compare if a string is equal to another string. But we can use things like greater than, less than, etc. with strings as well. So let's go to Atom to see how that might work. So far, we've mostly been using the equal to operator to check if two strings are equal. For instance, we could say print hello equals hello. And when we do this, Python should print out true because it is true that the string hello is equal to the string hello. When we run it, we can see that that's exactly what happens. And it probably makes sense that we can also use this when two strings are not the same. We can say print, for instance, help equals hello, and Python will go through and check whether these two strings are equal. What we haven't been talking about though is how Python does this. So because a string is a collection, Python goes through the entire collection item by item and checks whether those two items are equal. For instance, in the string help and hello, we would start with the H. Since those two are equal, Python is going to move forward one item and check the next item. Well, they're both E, checks the third item, they're both L. So far these two strings are equal. But once we get to the fourth item, we can see that the string help has the letter P and the string hello has the letter L. At this point, Python will determine that these strings are not equal. And that's essentially how it operates with the other comparison operators. For instance, we can say apple is greater than applet. And what Python will do is, as before, walk through each character in the strings and compare them one by one until it finds one that's different. For apple and applet, it would walk through the first 3, 4, 5 and say, well, these are all the same in both of these strings. So it hasn't been able to yet determine whether apple is greater than applet because so far they're identical. But when Python finally gets to the end of the strings, applet has an extra letter compared to apple, and so applet is actually seen as greater than apple. So when we print out the result of apple greater than applet, it'll actually print out false. Let's go ahead and do that. Print. So when we run this, we can see that Python says apple greater than applet is false. And that's because applet is the same as apple up till the end, and applet has an extra letter at the end, and so Python thinks that it is greater than apple. Let's look at this with another example. So we can say print Mac is greater than Mary. So again, Python will start at the beginning of the collection and compare items one by one. So the M and the A in both these strings are the same. The first time Python sees a difference is C and R. And Python is going to determine which string is greater by this third character. In this case, we are going to treat letters that are later in the alphabet as greater than, and so when we compare the C and the R in Mac and Mary, Mary is actually greater than Mac, and so if we print this out, we should get another false. And when we go ahead and run it, we can see that is exactly what happens. And this happens even if the strings are different on the first letter. So let's say print apple is greater than burrito. And actually, let's try a less than here. So when we go through this, Python starts at the beginning of the collection, and they're already different. And so we compare A and B, with B being greater than A, so we should actually get a true here. And when we run it, that's exactly what we get. Now, you might be wondering, what happens when we're comparing uppercase and lowercase letters? Well, Python can definitely compare those things. Let's print out lowercase a is greater than uppercase a. Now, this is a little bit less intuitive than when Python is comparing things in alphabetical order, but lowercase letters are actually considered to be greater than uppercase letters. So when we print out lowercase a is greater than uppercase A, we should get another true. And that's exactly what happens. Let's talk a little bit about string methods. Or I guess we should start off with what is a method in general. A method is basically a function that works for a certain type of object in Python. So string methods are functions that are specifically made to work with strings. And they work just like functions. The only difference is the syntax of how we call them. You're probably used to seeing functions like the print function, where we say the name of the function and put something inside the parentheses as an argument. That's just a general function, but we can also have functions that are string methods. When something's a string method, the way that we call it is by saying the name of the string that we would like to call it on, dot, and then the name of the method. So instead of saying upper as a function and then putting the string inside, we say string dot upper to call the upper method. Let's go to Adam to talk about some of the common string methods that you might use. Just to review, when we have a string method, which is just a function specially built to work with strings, we say a string like hello and then dot and the name of the method that we want to call. For instance, we can call the upper method in order to get the string hello as all uppercase. I'm going to go ahead and comment out this code from before, and let's go ahead and run it and print it out. So we're going to say print and hello.upper. And let's go ahead and run that. And you can see that Python returns our string, just now it's all uppercase. So as you've seen, things like upper, which is a string method, can be really helpful in dealing with strings. Let's get some user input from the user. We'll say user input equals input. Please type a phrase. And then we're going to go ahead and print user input the way that it comes in. And then we're going to print user input using the upper method that we just learned, so upper. And then we're also going to print it using the lower method. And if upper makes everything uppercase, you might have guessed that lower makes everything lowercase. So we're going to say dot lower, beautiful. All right, let's go ahead and comment out this line of code and run our program. So we're going to type in a phrase. I'm going to say hello. My name is Chelsea, and I'm going to hit enter, and you can see that as the string came in, we had a mix of both upper and lowercase. When we call dot upper, suddenly it's like we're shouting and everything's in uppercase, and then when we did dot lower, everything is now in lowercase. There's also some really useful string methods that return booleans to us. Things like is alpha, is digit, is upper, and is lower, which, as the name suggests, check if all of the characters in your string are alphabetical characters, are digits, are uppercase, or are lowercase. Now, I've mentioned a little bit before that when we get user input, it can often be messy. People do not always input the things that you think they are. And these is alpha, is digit, is upper, is lower can be really helpful in making sure that your user input is what you expect it to be. For instance, what if we asked the user for a number? We'll call this user input number. And we said, okay, I'm going to turn it into an integer because we're asking them for an integer. And I'm going to say input, please enter a number 0 to 100. Okay, so let's go ahead and comment this out and let's run this, but let's not be a great user. So it's asking us for a number, but let's say I put the word dog. Oh no. Okay, so when we do that, we get an error because Python is trying to turn the string dog, which is what our user inputted, into an integer. And Python's basically yelling at you, telling you, I don't know how to do that. Well, since we know that people are not always the greatest at giving input, we can use this isDigit function to make sure that what they gave us is what we expected them to give us. So let's go ahead and copy our line from before, but let's remove this integer function. So now we're going to go ahead and ask them for input, and then we're going to say, while not user input number dot is digit. And this is basically going to say, while they enter something that is not a digit, which is what we asked them for, print that is not a number, silly, and then ask them again to enter a number between 0 and 100. Once this while loop exits, it means that this not user input is digit is false, meaning they did give us a digit, and we can go ahead and turn it into an integer without any of the errors that we had before. So I'm going to say here user input number equals int user input number. So now if we ran our code, we can put dog, and it's going to say that's not a number, and we're going to go, oh, silly me, I meant to put 10, and it'll finally turn my number into an integer and exit that while loop. We can also use the isUpper function in a similar way. Pretend I'm asking someone to shout something at me through their input. I can say, input, please shout something. And I want to make sure that what they've typed is in all uppercase, representing the fact that they're shouting at me. I can say if not shout dot is upper, print I said shout. So let's go ahead and try this out. So we're going to run our code, and it's going to ask us for input. I'm going to not shout, and I'm going to say, hey, this is a whisper. And our Python program helpfully printed out I said shout, because we checked this if statement. If not, shout is upper. In other words, if not all of my characters are uppercase, print I said shout, which is exactly what happened. So let's try this one more time, but let's actually shout. We'll say shout. And when we run that, you can see that our if statement, our if suite, never had to execute because we did in fact shout all of our input. Now, one thing that's really useful is the fact that we can chain methods. So if we have a string, we can call .lower on it and then immediately call another string method like the replace method we'll talk about in a second, and then call another one and another one and another one. And we can do this all on the same line. So we're basically saying first do lower and then feed that into the next string method and then feed that into the next string method, so on and so forth. So in this case, it would say take the string, hello, what is your name? Make it all lowercase. It would replace my E's with 3's, then my A's with @ and then finally my O's with 0. And it would do all of this in one line. Again, this is called chaining methods because we're basically chaining multiple string methods onto each other at one time. And this is a perfectly valid way to run all of these methods. All right, let's do a fun example with the replace method and chaining methods. So the replace method is a string method where it takes a string, right? So we'd say string dot replace. And then the first argument is going to be what we would like to replace. And the second argument is going to be what we want to replace it with. So let's go ahead and use the replace method along with chaining methods to turn this string of Black Eyed Peas lyrics into the Kids Bop version of the Black Eyed Peas lyrics. So the replace method, we would call it by saying the string that we want to do it on, dot replace, and then the first argument is what we want to replace, and the second argument is what we want to replace it with. So let's start out our Kids Bop string by just saying Black Eyed Peas dot lower. And this is basically going to take our string and just remove any of the capital letters so that everything's lowercase. So when we replace one letter, we can know that it'll replace all of them and not miss any because some were upper or lowercase. All right, let's do some replacing and some chaining. So we'll say Kids Bop equals. And first of all, let's say Kids Bop dot replace. And remember, the first argument is what we would like to replace. So this is a word in the current lyrics that we don't want it to be there anymore. So let's say the first word that I want to replace is junk. And I'm going to replace it with the word stuff. And so when we run this, Python is going to look through our entire string, find any time that the string has the substring junk, and replace it with the substring stuff. Next, let's chain our methods and also replace, there we go, hump with pumps. So now we're talking about pumps like our shoes. And then let's chain one more. We'll say replace get with make. And we're not quite done yet, but let's go ahead and see what would already print out with just these couple of methods. All right, so first of all, we can see that everything is now lowercase, and we can see that the word junk has now been replaced with stuff. Hump has now been replaced with pumps in every single occasion that it appears, and get has been replaced with make. Now, we could continue chaining methods on here. The only reason I'm not is because there's only so much room on the screen. So I'm going to create another line and do some more chaining. So I'm going to say kids bop equals kids bop dot replace. And let's replace the word lumps, which is very inappropriate, and replace it with pumps. And then we'll say dot replace drunk, which very inappropriate for a children's song, with jump. All right, so let's go ahead and print out all of our Kids Bop lyrics now. All right, so you can see now compared to our original lyrics that we had, our Kids Bopified lyrics are much more appropriate for a younger audience, and we did it all with chaining methods and the dot replace method. Okay, now let's talk about the starts with method. So we're going to ask the user for input, and we're going to say, please enter my name is, and then your name in French. So if you've ever taken a French class, you know that how to say my name is je m'appelle. So we want to make sure that what they're writing is correct. So we're going to say if name dot lower, because you never know when people are going to write lower versus uppercase, dot starts with je m'appelle. Then we're going to print out great, because that is in fact how you say my name is in French. And the reason we use starts with is because everyone's name is different, so we're expecting people to say je m'appelle Chelsea or je m'appelle John. Whatever your name is doesn't really matter. We're checking to make sure that they've said my name is correctly in French. The starts with method will tell you whether a string starts with this string. So we're going to say is their input, what we're using here, starting with je m'appelle. So let's go ahead and test it out. We're going to run this. Please enter. I'm going to say je m'appelle Chelsea. And it's going to print out great because my string does in fact start with a je m'appelle. Let's try it one more time, but maybe let's get it a little wrong. So we're going to say my name is Chelsea because I didn't understand the question, and it didn't print out great because I didn't in fact do great because I didn't correctly say my name is in French. Let's talk about another method. This method again is really helpful when getting user input, and this is the dot strip method. So when we ask users for input, sometimes they add an extra space or an extra new line or some kind of white space at the end of their string. But we usually don't want that in the actual input. So let's grab some input from the user. So I'm going to say ID num equals input. Please enter your Chapman ID number. So when we ask them to input their ID number, we want just the ID number. We don't want any of the extra spaces that they may enter either at the beginning or at the end of the string. So let's go ahead and say ID number equals ID num dot strip. And then let's go ahead and print out ID num. Now when we run this, we can put extra spaces, and then we'll say my number is 1, 2, 3, 4, 5, 6, 7, 8. And when we print it out, you can see that Python has gotten rid of those extra spaces at the beginning. We can also do this with spaces both at the beginning and the end. So I could do space, 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 1, 2, 3, 4, 5, 6, 7, 8, blah, 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 extra spaces, so many spaces. And when we hit enter, you can see that Python again has gotten rid of or stripped the white space from the beginning and the end of the string. This is really important because, for instance, if you're checking if a password that a user entered is matching the password that you have for them, you wouldn't be able to do that if there's extra spaces or any white space at the beginning and end of the string. So we want to make sure that we're stripping that if we don't need it. Now note that this doesn't actually strip white space in the middle of a string. So if we run this, we could say my ID number is space, 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 1, 2, 3, 4, 5, space, 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 8, 9, 10. When you run this, it'll strip the white space at the beginning and the end, but not any of the white space in the middle. All right, last but not least, let's talk about the dot split method. Now, we'll come back to this when we get to lists, but I wanted to talk a little bit about it now because it is technically a string method. The dot split method will take in a string and it'll split it into multiple substrings. In fact, it'll return a list of strings. By default, the dot split method will split on spaces because that's often what we want to do to get multiple words out of a long string. So for instance, we could say print sentence dot split. And if we don't give this dot split method any arguments, it'll just split on the spaces. So let's see what that does. Awesome. So you can see that we have a list of all of the words in our original string because every time that there was a space, the method got rid of that space and just split our string there. But we can do this with other characters as well. For instance, say you had a string that represented a potential variable name. We could say print my variable name dot split and give it an argument of the underscore. Now, just like before, it's going to go through the string and find every instance of this character. And when it does, it's going to split the string there. So when we run this, you can see that it said this variable name is so long because every time there was an underscore, it split our string there. So now we have a list of strings. This is really useful if we ever want to, for instance, loop through all of the words in a sentence. We can split and then loop through the list of words. Again, we'll come back to this when we talk about lists a little bit more, but since it's a string method, we'll cover it here. There are a ton more string methods than the ones that we covered here, and I highly encourage you to look them up if you ever need them. These are the ones that we've gone over today, and hopefully the ones that will be most useful to you when working with strings. All right, that's all I have for you. I will see you next time.